In this video I'm going to talk to you about radians, which is a unit of measure of angles. You may be used to degrees. So what I'm going to do is I'm going to draw a circle. This is what we call the unit circle on a coordinate grid, where each, we know in degrees a full circle is 360 degrees. We also know the circumference of a circle is 2 pi r. Now, what a radian measure is, one radian measure is the angle it makes when the length is equivalent to, or the arc length is equivalent to its radius, r. This is its radius along here. We call that 1 radian. And this is why. How many radians can you get into a full circle? Well, how many radians? You divide the circumference by r, and you get that you can get 2 pi into a circle, which means 2 pi is equivalent to 360 degrees. So all the way around a circle, if we separate the unit circle into quarters, quadrants as we call them, the first quadrant, second quadrant, third quadrant, fourth quadrant, we begin at 0 degrees radians. Halfway round is pi upon 2 radians. A quarter of the way round is pi upon 2. Halfway round is pi. 3/4 of the way round is 3 upon 2 pi, or 3 pi upon 2, and all the way round is the circumference, obviously 2 pi, which is all the way round. And that defines what a radian measure is. Now let's go back to this formula here. We can use this formula to tell us how to convert between radians and degrees. So as we've said, the circumference all the way around of the unit circle in radians is 2 pi, which in degrees is equivalent to 360 degrees. So both sides can be divided by 2, giving me 180 degrees equals pi. And that makes sense with the unit circle, because if we look at what 180 degrees was if we were working in degrees, that's 0, halfway round would be 180 degrees, and we can see we've already written pi up there, so this makes sense. What we can then do is work out from here a formula. We can say that 1 degree is equivalent to pi over 180. That's a formula that's useful. And vice versa, we can do the other way around. We can say that 1 radian is equal to 180 divided by pi. The symbol we use for radians is a little c. So I'll just write that down there, a little degrees there. And we can use these two formulas to convert from radians to degrees and degrees to radians. Just cleared some space. We're now going to do some converting between them. So let's convert a 120 degrees into radians. So what we're going to do is I'm going to use this formula here, and I'm going to say, well, if 1 degree is worth pi upon 180, then 120 degrees is worth 120 pi upon 180. And it's simply just a case of simplifying the fraction that we have here. Exact radians are always left in exact values using pi. So we cancel it down, we get 2 pi upon 3 radians. So 120 degrees is equivalent to 2 pi upon 3 radians. I'm now going to convert 45 degrees into radians using the same method. You'll remember that on the unit circle, that would be a 90 degree angle, so half of that would be 45 degrees. Now, if this is pi upon 2, we should get a sensible answer, which is halfway between these two. So let's have a look. Let's use this formula. It's 45 pi upon 180, and then simplifying that gives us pi upon 4 radians, pi upon 4 radians, which is halfway between here. The unit circle goes anti-clockwise all the way around, by the way. We're now going to do it the other way around. Let's convert 5 pi upon 6 radians into degrees. So I'm going to use this formula down here, where I've got 5 pi upon 6. We can say 5 pi radians upon 6 is equivalent to 5 pi upon 6 multiplied by 180 over pi. That's an 80, by the way. Now it's just a case of multiplying your fractions together, simplifying where possible. Looking at this, the pi's cancel out. We can go 180 divided by 6. We can do that. So we get 3 there. 30. Apologies. And then 5 times 30 is 150. So 150 degrees is equivalent to 5 pi upon 6 radians. that's pretty much everything you need to know about radians and degrees.